Hello guys, Spency here. Welcome to another video from ChE. Today we are going to be tackling the first lesson of the second long exam, which is molecular species balance. But before all that, we have to review the basics of stoichiometry. In stoichiometry, we have the concepts of limiting and excess reactant. The limiting reactant is the reactant that will be consumed first if the reaction proceeds to completion, and the excess reactants are those that have leftovers if the reaction does proceed to completion. We could find out the limiting reactant by dividing the molar amount by the stoichiometric coefficient of all substances and getting the lowest value. As we shift from Chem to ChE, we shall introduce some additional concepts that will help us in our calculation. First, the stoichiometric coefficient is positive if the substance is a product, while it is negative if the substance is a reactant. Then we shall consider different characteristics of reactor performance. Conversion is the percentage of reactant converted. Mathematically, it is expressed as in minus out all over in. The yield of a product, on the other hand, is the ratio of the actual product to its theoretical. Now we are aware that not all products proceed to completion. Thus, yield is a good way to analyze this imperfection. Mathematically, it is expressed as this. The selectivity is the ratio of one product over the other, and mathematically, we could express it as this. Now let's move on. In chemical engineering, there are three reaction balances that you could do. The first of which is molecular species balance. The molecular species balance is a type of reaction balance based on the modification term and basic stoichiometry. Thus, our general equation becomes out is equal to in plus a modification term. Please note that the modification term for all substances is different, but could be related to one another through stoichiometry. A negative modification term indicates a substance being consumed, and a positive modification term indicates a substance being generated. The DOF for molecular species balance is unknowns plus reactions minus species minus other constraints. Let's consider the combustion of methane. If 300 moles of water enters a reactor and 400 moles comes out, determine the modification term of water. Thus, let's just plug in the values into the equation and we get the modification term for water, which is 100 moles. Another question. If 1,000 moles of methane enters the reactor, how much comes out? First, we have to relate the two modification terms. We know that the stoichiometric coefficient of methane is -1 since it is a reactant, and the stoichiometric coefficient of water is 2. Thus, we relate this by the equation shown. Plugging such into our general equation, we get our answer of 950 moles. Now let's discuss the pros and cons of MSB. One pro is it utilizes basic stoichiometric concepts. Thus, the shift from chemistry to chemical engineering is not that very difficult for us. Next quick calculation is when considering one reaction. Because in molecular species balance, if we are only considering one reaction, and since you're already familiar with stoichiometry, it's going to be a lot easier. However, this proves to be inefficient if we are going to use multiple reactions, and things are not going to be as quick as we thought it would be. It is also inefficient for complicated unbalanced equations, so if you don't know the complete balanced equation, this is going to be a difficult reaction balance to do. And we are considering too many modification terms, thus we are also considering too many equations, and we are going to have a simpler version of this in the next video, so we're not really going to use molecular species balance at all. However, we're going to be using it in this next chemical engineering problem. A reactor system was established so that the reactant stream with 40% molar sulfuric acid, 40% hydrochloric acid, and 20% potassium hydroxide, all at 1,000 moles per hour, will react through the equations shown. If the effluent stream contains 375 moles per hour sulfuric acid and 300 mole per hour hydrochloric acid, determine the complete composition of the effluent stream and the percent conversion of potassium hydroxide, the yields of potassium chloride and potassium sulfate, and the selectivity of potassium chloride over potassium sulfate. Now let's go to our calculation chamber and let us start solving this problem. Hello everyone, welcome to the calculation chamber. Now we are asked to solve that problem using molecular species balance. So like every good chemical engineer, we should start off with a diagram. So if I'm not mistaken, the diagram should be like this. This is the reaction chamber. So this is 400 moles of sulfuric acid, 400 moles of HCl, plus 200 moles of KOH. Then this should be 300 moles of HCl and 375 moles of H2SO4. Now we are asked to solve this using molecular species balance. So we're just going to plug in using our equations. So first it's going to be easier to get the modification term for HCl. So that would just be 300 is equal to 400 plus MHCl. Thus, our MHCl equates to 100. Additionally, it would be easier to get for H2SO4, which is using the same procedure. We get MH2SO4 as equal to 25. Now, what have you noticed here? Oh, sorry, I forgot to put the negative sign. So it's negative 25 and negative 100. Now we notice here that these are both consumed while the reaction was going on, which makes sense because they are reactants in the first place. Now if we want to get the products, let's say MKCl, the modification term for, let's say, KCl, we just use the stoichiometric coefficients. That's 1 for KCl over negative 1 of MCl. So we get here, so more or less this is equal to 100. Thus, we get our moles of KCl is equal to 100. Because there is no KCl going into the reactant. Okay? Next, we are going to use KOH. Before KOH, we're going to use K2SO4. So MK2SO4, let's do the balances again. So K2SO4, that's just 1 over negative 1 M of KH2SO4. So that's equal to 25. So NK2SO4 is equal to 25. Now, 2 down, 2 more to go. Now, let us consider MKOH. Now, since MKOH comes from 2 separate equations, we should consider them both. So, we have the modification terms for HCl and H2SO4, so we're just going to use them. So, the relationship between MHCl and MKOH is simply 1:1. Right? So it's negative 1, since they're both reactants, over negative 1. Then you get MHCl. Then we add the relationship, which is negative 2, since you need 2 KOH to react with 1 mole of H2SO4 over negative 1 times MH2SO4, which we will get negative 150. I hope everything is clear so far. You could pause the video to reflect if you need more time to grasp on the concept. So our NKOH is equal to the initial amount, which is 200, minus the modification term, which is 150, which is equal to 50. Alright? Now let us consider H2O. It's basically the same thing here, except that this will become positive and this will become negative. So this will become positive over negative, since this is a product, MHCl plus 2 over negative 1 of MH2SO4. Then you will get positive 150. Plugging into the equation, our H2O levels are 150 moles. So now we have the complete composition of KCl, K2SO4, KOH, and H2O. Now let us use our data to calculate for the conversion. So conversion basically is the amount in minus amount out over amount in, which is approximately 75%. The selectivity, on the other hand, is the amount of desired product, which is the KCl, divided by the undesired product, which is K2SO4. So you get 4. Then the yield of KCl is approximately what came out over what is the theoretical amount, which is 200. Because if we assume that all KOH turned to KCl, it will amount to 200 moles of KCl, which is 50%. Additionally, if it's K2SO4 using the same logic, we would get 25 divided by 100, which should be 25%. So these are our final answers. So this is a complete composition of our effluent stream, and these are our statistics. So there you have it, guys. So this is how you solve the problem using molecular species balance. I hope that you have learned something from our concepts video, from the concepts part until the calculation part. So that was our video, guys. Thank you for watching. If you want to subscribe to our channel, you could do so with the logo above. And if you want to check out for more 101 videos, you could click on the video down below. Thank you for watching, guys, and good luck on your long exam.